Hello everyone, I welcome you in lecture number 7 on partial derivatives. In this lecture we will discuss 3 more examples on partial differentiation. So we start with example number 1. Verify that the function u equal to e to the power minus alpha square k square t times sin kx is a solution of the heat conduction equation del u by del t equal to alpha square del square u by del x square, where alpha and k are constants. So we have to show that this function u, which is a function of two variables, here u is a function of two variables t and x. So u is a function of t variable, so we can talk about partial derivatives of u with respect to x and t. So we have to show that this function u is a solution of this equation known as heat conduction equation del u by del t equal to alpha square del square u by del x square. So we know that this u is a solution of this equation if it satisfies this equation. So we have to calculate del u by del t and del square u by del x square, and we have to check whether del u by del t is exactly equal to alpha square times del square u by del x square or not. So we first start with finding out derivatives of u. So first we differentiate u with respect to x. So we consider another variable t as constant. So because t is constant, e raised to minus alpha square k square t, this function becomes constant, and derivative of sin kx is cos kx into derivative of kx with respect to x, which is k. So here we are applying chain rule. First we differentiate sin function. Derivative of sin x is cos x. Here instead of x we have k into x, so we write cos kx, and in the product we have to write derivative of kx, which is k. This we can rewrite as k times e raised to minus alpha square k square t times cos kx. Now we again differentiate this partially with respect to x. So this k times e raised to minus alpha square k square t becomes constant, and derivative of cosine function is minus sine function, and in the product we will write derivative of kx, which is k. So this is constant, k times e raised to this derivative of cos kx is minus sin kx into derivative of kx, which is k, and this we can rewrite as k into k minus k square. This negative sign we have written here. This function as it is e raised to minus alpha square k square t times sin kx, and if we multiply both sides by alpha square, we obtain alpha square times second order partial derivative equal to this right hand side multiplied with alpha square. So we give this number 1. So we have obtained alpha square times del square u by del x square, and now we find out partial derivative of u with respect to t. So we will consider sin kx as constant, and derivative of e raised to this is e raised to minus alpha square k square t into derivative of minus alpha square k square t with respect to t, which is minus alpha square k square. So that we have written here partial derivative of u with respect to t, and this we can rewrite as minus k square alpha square e raised to minus alpha square k square t times sin kx. So if we compare equations 1 and 2, right hand sides are same, therefore we can say that del u by del t equal to alpha square times uxx. That means given function satisfies this equation, that is given function u is a solution of heat conduction equation. So sometimes they ask us to find out or to verify that given function is a solution of given equation. So here also we have applied chain rule. We consider another example. Show that the function u equal to e raised to x times sin y is a solution of Laplace equation del square u by del x square plus del square u by del y square equal to 0. So here u is a function of two variables x and y. So we have to calculate partial derivatives of u with respect to x and y. So first we write down given function, which is u equal to e raised to x sin y. Partial derivative with respect to x is sin y as it is, because it is constant. We are differentiating with respect to x, therefore y is constant, therefore sin y is constant, and derivative of e raised to x is e raised to x. And if we differentiate with respect to y, we consider e raised to x as constant and derivative of sin y is cos y. Now we find out partial derivative of del u by del x with respect to x. So derivative of e raised to x sin y with respect to x, sin y is constant, derivative of e raised to x is e raised to x. Similarly, we differentiate del u by del y with respect to y. So here e raised to x as it is, because derivative is with respect to y, therefore e raised to x is constant, and derivative of cos y is minus sin y. So this we can rewrite as minus e raised to x sin y. And if we add these two second order partial derivatives with respect to x and y, then we can see right hand side is e raised to x sin y minus e raised to x sin y equal to 0. So therefore u equal to e raised to x sin y satisfies Laplace equation del square u by del x square plus del square u by del y square equal to 0. Next function is u xt. U is a function of x and t given by sine of x minus at, and we have to show that this function satisfies the wave equation, which is given by del square u by del t square equal to a square times del square u by del x square, where a is a constant. So here we have to find out second order partial derivatives of u with respect to x and t. So we write given function is u equal to sine of x minus at. So if we differentiate with respect to x, we consider t as constant, and before that we apply chain rule. By chain rule, derivative of sine function is cosine function. So derivative of sine of x minus at is cos of x minus at into derivative of x minus at with respect to x, which is 1 minus 0, that is 1. Similarly, if we differentiate u partially with respect to t, we consider x as constant. So derivative of sine of x minus at is derivative of sine is cos function, and in the bracket partial derivative of x minus at with respect to t. So derivative of x is 0 and derivative of minus at with respect to t is minus a. So here we write minus a. Now again we find out second order partial derivative with respect to x, that is partial derivative of this cosine of x minus at with respect to x. So which is derivative of sine is minus sine x minus at into derivative of x minus at with respect to x, which is 1. Same thing here, we differentiate del u by del t with respect to t. Before that we have written del u by del t in this way, minus a times cosine of x minus at. So if we differentiate this with respect to t, we consider x as constant, and first we write minus a as it is constant. Derivative of cosine function is minus sine x minus at into partial derivative of x minus at with respect to t, which is minus a, and this minus a into minus a will be a square, and we write this negative sign here, minus a square sine of x minus at. But we can observe here del square u by del x square is minus sine x minus at. So this we rewrite in this way, a square times minus sine x minus at. So if we compare 1 and 2, or if we put value of equation 1 in 2, we can see this bracket is nothing but del square u by del x square. So using 1 into we obtain del square u by del t square equal to a square times del square u by del x square. So hence given function u satisfies wave equation. So in this lecture we have discussed examples on partial derivatives, and we have applied chain rule to calculate sum of the partial derivatives. So I stop here. I hope you like this lecture. Thank you very much.